Okay, step one, tent stick, metal stake, into the ground, outside, where there's dirt. Wet dirt would be better. There we go. I have plant sprinkler system. Perfect. Step two is to connect the cord to the cable, and we're on the second floor where we have a really long cord, and go downstairs, connect it to the tent stake. You can use anything you want to connect your tent stake to the cord. I use this here grabber thing. The meter I use is a Fluke 83. It's good for voltage down to 1 millivolt. It's also reads microamps. Required to read current on the grounding system. But if you're not going to read the current on the grounding system, you don't need this expensive meter. But if you're going to buy a meter and you really want to do everything, this is the meter. So one end of this cord that's going downstairs can actually go into either common or voltage. Technically, common's called the ground. The other end is going to go to this homemade thing. It's just a piece of pipe to hold on because I want to read the voltage on my body relative to the ground outside. Now, you don't need a piece of pipe. You could literally just touch the bare end of the wire. If you remove the wire, this is just for convenience. But as long as you're touching the wire. The ironic thing is with this voltage on the body, it's not my finger, it's my body will have the same voltage everywhere because it's got water in it, probably why. But this is why when you're laying on the bed, it makes a difference. The reading on the meter is going to be different laying on the bed than standing up because your feet, your head, if it's close to the wall where there's an outlet, then you're going to have the same voltage on your feet or on your whole body. So as long as you're touching the end of the wire or a piece of pipe, whatever you connect your wire to, your multimeter, and the other end goes to ground, you're good. And I'm going to turn it on. This is alternating current volts, and this is DC volts like you'd have in your RV. So we want it to be AC volts. See AC, millivolts. Now I'm not holding anything, and I'm standing in the middle of the room. So if I touch it, there's actually 2 volts on my body right now. Notice the little V will go to millivolts. So 240 millivolts is 0.2 volts. When I touch it, that's the voltage relative to the ground. So apparently I'm a better antenna than that piece of pipe, is how I would view that. I'm standing, but above my head is a ceiling fan. Also by my feet, could be wires in the floor. Pipe technically is in the middle of the bed. Maybe it's not near any wires. This is the point of doing this exercise. It doesn't matter where you put the meter, it's where we put this in our body. Okay, now I'm laying on the bed and it's 2.2 volts. The purpose of this exercise is to see what would happen if I unplugged the lamps next to the bed. It's ideal if 2 people do this because as soon as I move my body, even if I leave the meter there, I'm not going to come back and sit in the bed in the same spot. Of course, it gives you the opportunity to actually see, well, if I get up and down and out of bed in the night and back and forth, what's the difference? 2.1, 2.2 volts. So I got this lamp next to the bed. I'm going to go unplug it from 2.2 volts, just this one lamp. Get back on the bed. So it didn't change a whole lot. It's only down to 1.8 volts. So there is another lamp on the other side of the bed. We're going to unplug that one too. Now we're down to 1.5. We lost about a half a volt. It's good to have a piece of paper, write down which lamp you unplugged, which side of the bed, what's the best bang for the buck. So why am I still at 1.5? Because there's wires in the walls. I'm going to move around on the bed, go from one side to the other. Doesn't make a difference. The issue is there's wires in the wall, and even if we have nothing turned on, as long as the power's on. So the next thing we're going to do is go downstairs, shut the circuit breaker off, and see what the difference is. Really wanted to see, okay, will I sleep better if there's no electric field? And maybe if it's worth it every night, go down, shut a breaker off, we'll do that. So we got 1.3 volts, both lamps unplugged. I'm gonna go downstairs to turn the breaker off. But before you do that, you wanna make sure you shut down your computers and everything. The breaker box. FYI, do this at your own risk and call an electrician if you need help. Quite often these are not really marked very well. I'm gonna look for the one upstairs bedroom. The bedroom's above the kitchen. Unless we shut the kitchen off too, we might not drop that well. Also, we're in a condominium, which is really tough because there's going to be people on the other side. Range, dryer, air conditioning, double one. Shut stuff off. I'm going to go back upstairs. The way to tell, of course, is the lights go off. Well, lights went off and all the lights went off. I've got a notebook here because what we want to do is keep track of the breakers and the voltage. So let's see what it is now. Awesome, see, that's what we want. 138 millivolts. Round this off, by the way, don't get stuck on numbers. I'm gonna call it 140 millivolts. And I'm gonna write that down. Millivolts, bedroom, breaker off. And actually, it's even better if we go find out what that breaker number is and write it down. Well, probably gonna need one of those. Battery operated clocks. Flashlight, maybe. I'm gonna go back downstairs and record breaker number. Breaker number 17. I need to turn off 17. And when you're done, turn it back on. Close the panel. I'm gonna go back upstairs and show you what happens when now we turn the power back on. Okay, I'm back upstairs. I've turned all the power on. I also plugged the lamps back in. And I kept track of my data. Ideal, breaker off. It's good to write the numbers because you see we started with lamps are plugged in, normal, 2.3 volts. We kind of cut it in half, but not really half, but took it down by unplugging the lamps. Just turn the breaker off is ideal. We're lucky we can do that. Some buildings you can't. And even if you own your own home, sometimes the master bedroom is above the kitchen or there's wires running in the ceiling or someplace. You can't get it down unless you shut other things off. We're lucky here. What do the numbers mean? I can reference my own book here, Unplugged. So ideally, we would have 100 millivolts. We got 140. That's pretty good. I like that. If we don't do anything, 2,300 millivolts. Well, it's kind of on the high side. Truth is, most people's houses have 1 to 2 volts, maybe 2 to 3 volts. That's pretty much normal. Doesn't mean it's okay. Unplugging stuff helps. Turn the breaker off is really the best thing to do. Some of the meters that are sold, grounding cloths, they will tell you to plug into the outlet. So I'm curious to see what the difference is if we use the outlet instead of 2.2. That's with the tent stake. And I'm going to switch it over to the outlet. The outlet says 1.8, maybe 1.9. The tent is about 2.15. Versus 1.85, that's 0.3 volts. That's quite significant. That's 300 millivolts. Outlet is going to give you a lower reading than the reality one, the ground one, which is what we want. The chart in this book, like what do the numbers mean? These are based on relative to earth ground outside, not electrical outlet. So you're really confounding how you interpret stuff. Of course, it still would work. You could still see whether you use the outlet or the tent stake. If you unplug stuff, turn the power off, things are going to go down, down, down. Okay, so I shut the power off, the breaker 17 again. Interesting, we're at 203, let's call it 200 or 205 millivolts. It went up. The outlet, that's only 40 millivolts. 35 millivolts is only 0.035 volts. It's a small difference. That, by the way, is why if you get a grounding sheet, those earth protection sheets, you do not plug it into the ground outlet. You plug it in outside into a tent stake, because if you plug it into the ground outlet, you're going to have a small voltage on yourself. You're not going to be like camping outside. So I'm on the second floor. I could easily slip the cord, goes outside the door, and this is sloppy. I'm just doing this just to do it quick. And it's a rental. I could easily stealthily put it next to the building and run it out to the garden. without anybody really knowing. My neighbors might wonder if I'm doing a new kind of satellite dish. Okay, so the other reason we have this expensive meter, the one that reads microamps, we can clamp onto water pipes and wires and see if there's any current on the grounding system or wires, but only if we have a meter that reads microamps and only if we have one of these jaws. You'll find electricians that have smaller jaws. The jaws are built into their meter. That's not good enough. The way electricity magnetics works is, this is really sensitive because there's copper coils, a lot of copper coils. The way you read current in magnetic fields is, whenever current's flowing, it creates a magnetic field, which creates a current in the wires. The more wraps you have, the more sensitive it is. For normal electrical work, you can get one of these with some jaws, it will read, but we're trying to read small currents, so you need big jaws. You can still find these though, not cheap. This one's gonna go into microamps and instead of voltage. I'll show you what to do with this, where we're gonna check for current. To use this meter, you're gonna turn it to amps, microamps. This setting can do microamps both the alternating and direct. So you see it's on direct current, we want alternating current. So now it's on alternating current, microamps. Let's go take some readings. Where you want to check is where the water comes into the house. So in this case, we got plastic pipes which don't conduct current. So this is ideal, it's a newer house. In an older house, this would be metal. So you find where the water comes into the house, there's a shutoff. And with the jaws, you simply clamp around the pipe. You should see 0. Hot water heaters are another place. Often you'll see the water come into the house. You just basically do this anywhere you see pipes. You clamp on and you should see 0. It doesn't matter which pipe you do. Another thing is gas pipes. You can clamp onto a gas pipe. Now you say, how could I possibly have current on a gas pipe? It's because electric stoves, electric ovens, electric hot water heaters, even outlets, sometimes electricians will ground stuff to metal pipes, even the gas pipes, especially in a crawl space. Go into your crawl space and look, and you'll see contractors. Only should it be one spot, the ground connected to your water pipes in any building, and that's at the main panel. Either way, should always be 0. Another common place you will find current on the grounding system is where outside the phone or the cable hooks up to, comes into the building. The cable company and the phone company, they need to use their own ground and not the same ground that the fuse box and the electrical power is using. Because when that happens, the current from one of the other cable or television gets on your electric wires, and you tell your cable TV people and your phone company to disconnect that, put it in their own ground.